Hello everybody. This video will be a tutorial on RocData, how to use it to analyze Triaxial tests and apply it to rock mass. So please read the problem text in the description of this video. I'm just gonna only briefly go through it so that you have some idea what we're dealing with. So we're gonna have a tunnel, and the tunnel will be in the basalt. So the tunnel will be excavated at the depth of 110 meters. And site investigation gave us some idea about geological strength index, which is equal about 85. So the disturbance of the surrounding area using the TBM machine will be minimal. And what we need to do is we need to estimate the strength characteristics of this rock mass. And to do that, we collected some core samples of basalt, and we have data that we're going to plot right now. So the first thing that you will do, just go to analysis, project settings, make sure that it's set for generalized Hook-Brown. So that's what we're going to use. Click here, OK. And now we're going to plot the data from the laboratory tests. And in this case, you can click this button that says use lab data. And then you'll see here you have sigma 3 and sigma 1. So just check the description of this video. The data should be there. I'm gonna put it 0, 5, then here will be 10, 20, 50, and 100. So that's confining pressure for each test, and major principal stress will be 155.1. So this one will be 195.4. Next one, 235.2, 82.4, 440.3, and for the last test it will be 639.2. Okay, so we plotted the data, so we put it in this spreadsheet that looks exactly like Excel spreadsheet. So now we're gonna go down here, and we're gonna find the curve fit analysis algorithm. We're going with linear regression. There are a few options, but they're pretty similar. So I usually go with linear regression, error summation vertical, and error type absolute. Okay, so once we do analysis, you will see that here it says lab material 1. It has data on the intact uniaxial compressive strength, sigma Ci. So this is UCS, this is unconfined compressive strength. So that will be for these rocks. That's the analysis, 149.3 MPa. And also MI, the one that has been used in Hook-Brown criteria, it's 17.8. So it should be close to the typical value of for basalt. Okay, so this is what we get from the analysis of these 6 tests on basalt. And now we're going to apply it to the rock mass, to the tunnel at the depth of 110 meters. So what we need to do is we need to synchronize. We click here, sync, then tick the box, synchronize, material 1, OK. So, and after we synchronize, we're going to add additional data. So we'll click this button which says use reference tables. Okay, you're gonna click this button, and then you see that you have sigma Ci, and that's the value that we have already obtained from the analysis, and it's grayed out, so you cannot change it. We have also Mi, which is grayed out, so we cannot change it too. There are a few things that we can change, and we are already given this information, so we're going with geological strength index. We know that it's 85, so we can just type here 85. Sometimes if we don't know, if we just given some idea like blocky structure and things like that, we click this button, uh, pick from the table, and then based on the description that we are given or we have obtained from the site investigation, We can decide on the structure if it's blocky, and also look at the surface conditions, good and or very blocky and good, right? So then you just pick any point here. You will see that it changes 60 here, here 70. So we're given 85. So we're gonna go with 85. So I'll just type it back 85. Okay. So next one is disturbance. So we click this button and we have two options. One option for tunnels, the one is for slopes. And as already mentioned before, we deal with tunnels. So we keep tunnels ticked. And then it says use TBM, and the results is minimal disturbance. So D, we just click D equals 0, which is the best case. There is no disturbance. We would like to see D to be 0. So when there is lots of disturbance, very giant rock mass, D will become 1. We click OK. And the final piece that we'll need to do is we will need to decide on the application, because this application will adjust our principal stresses. And we open this one, the menu, and say we choose tunnels, and then we are going to add the depth. So we change it to 110 meters, and the unit weight is already preset. So it's usually 27 kilonewtons per cubic meters. That's the average unit weight for rocks. So in this case, it's meganewtons per cubic meters. So we're not given any information. In this case, we just keep it as it is. And that's what we need. So this is the data that we're going to get. So we still have this UCS. It didn't change, 149. But you will see that when we applied it to rock mass and we put here JSI 85, uniaxial compressive strength decreased to 64. So that will be the value. Tensile strength will be 2.699 MPa for the rock mass. So, and its tensile strength, that's why it's negative. We have all these constants, S and A, sorry, alpha. And also we have estimation of cohesion and friction angle based on the Moore-Coulomb failure criteria. So sometimes it's necessary to have it, especially when we deal with rock slopes and we would like to know more about shear strength that we can use for slope stability analysis. That's why we need to know cohesion friction angle. You see this is pretty high. So just to show you, if let's say we go back to JSI and change it to 100, which means that there are no joints, nothing, no discontinuities, you will see that this value also change. Uniaxial compressive strength 149 is the same that we have for rock samples that we tested in triaxial compression. It's just because there is no discontinuities, so discontinuities don't change the strength of the rock, which is probably the best case. Let's play with this one and say, for example, JSI, geological strength index, is 50. Let's look at this. Let's say it's maybe very blocky. We have lots of discontinuities. And when we look at surface conditions, they just fair. So probably click somewhere here, 48. Okay. You see how the value of UCS dropped to 7 from 149 to 7. And also the tensile strength also dropped to 0.166 MPa. This shows the importance of discontinuities, that discontinuities can actually greatly affect the overall strength of rock mass. Well, that's it for this tutorial. I hope you've learned how to use RocData and how to analyze data from triaxial tests and apply it to rock mass conditions. Have a nice day. Bye.